Greetings and welcome to the Astronomy Picture of the Day podcast. Today's picture is titled Io in True Color. So, what do we see here? Well, this is one of the four large Galilean moons of Jupiter, and Galileo saw these four as individual stars which appeared to be orbiting around Jupiter, and they're later determined to actually be satellites of the giant planet. Now, Io itself is the closest of these and is actually very similar in size to our moon. It's about the same size as our moon, and it actually orbits at about the same distance from Jupiter as our moon. However, that's where the similarities end. Io itself has no craters. Our moon is loaded with craters, has a very ancient surface. Io has the youngest surface in the solar system among solid objects, and that means it has no impact craters on it. And that's because it is extremely volcanically active. Now, based on size and distance from their planets, you might think they'd be about the same. However, the difference is Jupiter is many times more massive, over 300 times more massive than Earth. So while they're at the same distance, the tidal forces that Jupiter exerts on Io are vastly greater than the tidal forces that Earth exerts on our moon. And essentially what that does is constantly squeeze Io as it moves around in its orbit. It twists a little bit because of its interactions with other moons, and therefore it keeps getting kneaded inside, if you want to think about it like a big lump of clay that's been kneaded for billions of years, and that keeps it extremely hot and active inside, to the point that a large portion of the surface is covered by warm lava, and that all impact craters, while it gets hit just as much as any other object in the solar system, they are wiped out very quickly. Now, this is what is known as a true color image, so it's been adjusted from actual images to make it appear what it would look like if you were out there near Io looking at the surface yourself. This is about what the typical human eye would see in terms of those colors. And we can see that there are some differences, that there's some browner colors up towards the polar regions, both the north and south polar regions, and a much more yellow color present. Now, a lot of this is due to molten rock and from sulfur that is erupted from the interior. So we have molten silicates, ordinary silicate rocks, and we have combinations of sulfur there, which different concentrations give us some of these different colorings that we're seeing in our image. So studying this, and this was done by the Galileo spacecraft back in 1999 when it orbited Jupiter in that time frame and took many images of the large moons as well as Jupiter itself. And of course, one of the objects that astronomers wanted to study was this extremely active moon, the most volcanically active object in the entire solar system, much more active than Earth, which is the other object which has this type of volcanic activity that we know of in our solar system. But it is many times more active, completely, at least a large portion of it, covered in lava. And all of the material that you see there and what might look like little craters are actually volcanoes. So very heavily volcanic, much more so than even our own Earth. So that was our picture of the day, titled Io in True Color. We'll be back again tomorrow for the next picture. So until then, have a great day, everyone, and I will see you in class.